Welcome back, everybody, and we are discussing solutions. So let us do a quick overview. Last time we were talking about solutions, right? And we said that a solution is what? We said a solution is a dispersal, oops, not just a dispersal, a uniform dispersal of one substance throughout another. Substance throughout another. Cool. All right, that seems easy enough. And that there are components to a solution, and one of those components is a solute, and that is the substance in lesser quantity. And there is a solvent, and the solvent is the substance in greater quantity. That's great. And then we talked a little bit about the process of making a solution, and that process is called solvation. And a subset of solvation is hydration, and that is solvation in which, yoink, in which water is the solvent, right? And then we said, hey, that process really has 3 steps to it. Number 1, we have to overcome the forces of attraction between my solute particles. We're not talking about breaking the bonds of a molecule here, are we? We're just talking about, if it's a molecule, we're talking about overcoming those IM forces, intermolecular forces. And then we have to overcome the forces of attraction between solvent particles, right? And usually, once again, we're talking about overcoming those intermolecular forces, unless, of course, it is an ionic compound. And then 3, because of an attraction between solute and solvent, then my solvent particles surround my solute particles. And we have a solution. Cool. Now, what I want to start with today is the concept of how can we classify solutions. And we can talk about 3 types of solutions. There is 1, a saturated solution. 2, maybe I'll need more space. Tell you what, let's go down here. Zoink! We're going to need more space for this. I know this already. Do-do-do-do-do. Do-do-do-do-do. Oops, oh no. Got to get rid of my eraser. Do-do-do-do-do. Do-do-do-do-do. There we go. Okay. So what can we have here? I can have an unsaturated solution. I can't spell. Doink. We'll get out of here. Go. Bye. Leave me alone. Unsaturated solution. We can have a saturated solution. And we can have a supersaturated solution. Okay, good. And if we look at our question here, we see we have to understand that, right? Consider copper 2 nitrate solution. Is this a saturated solution, a supersaturated solution, or an unsaturated solution? And when I look at this picture, what do I see? I see an area that looks like it's just liquid, and then I see an area down here that looks like it's a solid. So it looks like I have a liquid and a solid, right? Good. Can that be a could that be a solution? Well, solution we said is um, uniform dispersal. Is that uniform down here? I'm not sure if it is. Maybe we better go back and get some more of these definitions here. Let's start with a saturated solution. Here's my definition of a saturated solution. This is a solution in which an equilibrium exists between dissolved solute and undissolved solute. Okay, I'm not sure I understand this here. Well, let's think of taking some sodium chloride solid, and we're going to add it to some water, right? And as I start adding my sodium chloride, immediately my sodium chloride starts breaking into ions in an aqueous solution. So it goes into solution. That means it's no longer solid, and I'll have some sodium plus aqueous and chloride minus aqueous, right? And they are surrounded by the water. We overcame the ionic forces in my sodium chloride. We overcame the hydrogen bonding in my water, and now my water surrounds my sodium ions and my chloride anions. But if I keep adding more and more of this, eventually there's not enough space between my water for the ions to exist, and I'll start getting a lump of solid at the bottom, and this is really NaCl that is solid. I've added too much sodium chloride for all of it to dissolve. So now I have, what do I have actually present? Well, I have solid sodium chloride and I have aqueous sodium chloride. This would represent my dissolved sodium chloride, and this would represent my undissolved sodium chloride. And what happens is some of my solid will go into solution, meaning it'll go up to form sodium ions and chloride anions, and they'll be surrounded by water. And others of my sodium chloride that are in solution will then get knocked out of solution and reform into the solid. And that's when those rates are equal, we call that an equilibrium. And so if I look at this from an equation standpoint, we would write it this way. Okay, and this represents an equilibrium. How do I know it's an equilibrium? Well, usually we'll always see a reversible reaction, and we're going to assume that's an equilibrium unless someone tells us otherwise. And notice, this represents my undissolved solute, and these guys represent my dissolved solute, and so I have an equilibrium between my undissolved and dissolved solute, and that would represent what? A saturated solution. Whew! That is heavy, sure is. Now, what about an unsaturated solution? Well, that's a little easier to understand. This is a solution in which there is insufficient solute to create a saturated solution. What do we mean by insufficient? We don't have enough. This is a solution in which we have not added enough solute to create a saturated solution. All the solute is dissolved. So all of the solute is dissolved. There's not enough solute to force a precipitation to occur, and so there is no solid. It is all dissolved in my solution. or in my solvent, excuse me. And then what's a supersaturated solution? This is a solution in which there is more dissolved solute than in a saturated solution at similar conditions. And this is really an interesting animal, these supersaturated solutions. Number one, they are very unstable. If I shake them, or if I add a seed crystal, so if I add a seed crystal, they will precipitate and form a saturated solution. So they are tough to make, and sometimes, usually what I have to do is, quite often I have to heat the solution, add lots of solute, and then carefully cool. And that's how I can make a supersaturated solution. Now, don't worry about this. I'm just telling you that for fun. But that's our definition, and now let's see if we can put this together. Here we go. I have this picture, right? What do we notice? I have a liquid phase and I have a solid phase. This liquid phase represents what? Well, I've got water as my solvent. And what's in that water? Well, my solute is going to be dissolved in that water. So I'm going to have Cu2 plus aqueous, and I'm going to have NO3 minus aqueous. Right. Well, what's the solid down here? Well, that solid isn't going to be frozen water, is it? No, that is my copper 2 nitrate. And it's in the solid form. And what do we have happening here? Well, some of this is going that direction, and some of these guys are going that way. And eventually, those rates are equal, and I'd have copper 2 nitrate solid going to copper 2 aqueous plus 2 nitrates aqueous. And if that's the case, then what do we have? That is a saturated solution. Cool. Yes, it is. Whenever I see that, that means I have a saturated solution. Excellent. You guys try this next one. Okay. I look at this and I say, hey, there's no solid down here, so it's not a saturated solution. And so then I look at this and I say, oh, well, if it's not a saturated solution, it can't be a supersaturated solution, right? So it must be an unsaturated, right? Well, no. Hey. We know it's not saturated, but do we know it's not supersaturated? When we go back and look at our definition, what did we say was the definition of supersaturated? A solution in which there is more dissolved solute than in a saturated solution at similar conditions. Aha. Be careful here, people. This could be supersaturated. Superated, no. How about supersaturated? Or it could be unsaturated. I can't tell just looking at it. Now, how might I tell if it's supersaturated? Well, I could add a seed crystal. And if I added a seed crystal and then it precipitated, we would know that that is supersaturated. Or I could shake it up. If I added a seed crystal and nothing happened, then I would know that it's unsaturated. But this is kind of a trick question. We don't know by looking at the picture. It could be either one. Got it? All right, here we go. Next question. Let's add 5 grams of copper 2 nitrate to a saturated solution. What type of solution do you have? Okay, so coming back here, right? We're going to add 5 grams of copper 2 nitrate So I want to drop in here 5 grams of copper 2 nitrate. What happens? Well, what's going to happen? I'm actually just going to get more solid down here, right? By adding that 5 grams, I get more solid down there. Has this become unsaturated? No. Has it become supersaturated? No. It is still a saturated solution. This is something that is counterintuitive for us when I have a saturated solution. So if I have a saturated solution and I add more solute, what do I get? Hey, I still have a saturated solution. It is not supersaturated. Remember, for me to get a supersaturated solution, I have to heat it up or in some way increase my solubility, put more solute in there, and then carefully bring it back to normal conditions and hope that it does not precipitate. But this is what I wanted you to understand is by taking a saturated solution and adding more solute to it, you still only have a saturated solution. Okay? Well, I think that's enough for today. Bring me back next time, and we will talk about what? Electrolytes. I like electrolytes. Have a good one, folks. Ciao.